The low-temperature thermal treatment unit is designed to remediate soil contaminated with a variety of organic compounds, such as petroleum, coal tars, and specialty nitrated compounds. This is accomplished by separating the contaminants from the soil with heat, then elevating the temperature in an oxidizer to thermally destroy them and control emissions.
Contaminated soil is characterized through sampling and analysis. Each project is uniquely identified and is transported to the facility for treatment. Loads are weighed in at the truck scale and recorded in the scale system computer. Soil is received into the storage building where it is pre-processed. Amendment products are added to reduce the moisture and break down the cohesive properties of finer-grained soils. This allows the soil to flow steadily through the unit. Once the soil is amended, it is fed to the pre-processing unit with a front-end loader. The grizzly removes objects greater than 9 inches. Combustibles are hand-sorted and disposed of as an incidental waste. Ferrous metal objects are removed with a self-cleaning magnet mounted on the conveyor system. Remaining material is processed through a jaw crusher that reduces any materials to a maximum of 3 inches. Fully pre-processed material is stockpiled for subsequent handling. Material is taken from the pre-processed stockpile and fed to the thermal treatment system. This is where the soil recycling takes place. The soil is conveyed to a plant-mounted screen deck to remove rocks or debris greater than 3 inches. Following this secondary sizing is an incline belt with a continuously reading weigh scale. The belt scale provides soil feed rate and totalized weight to the unit's control system. The feed belt delivers the contaminated soil to a rotary drum dryer where desorption and separation takes place. The rotary drum dryer is the primary component of the system. The drum is arranged with internal flights that lift and drop available soil through the hot gas produced by the direct-fired primary burner. Soil flows through the length of the dryer as it rotates. The burner is located in a combustion zone at the end of the dryer. The soil discharges the dryer at temperatures of approximately 450 to 950 degrees Fahrenheit. The operating set point of the dryer is determined by the boiling point of the contaminant and any regulatory requirements as specified in the operating permits. Soil residence time in the rotary drum dryer is variable and is a function of the rotation speed and depth of fill desired in the system. At a feed rate of 30 to 40 tons per hour, the soil residence time will be approximately 8 to 10 minutes. The gas stream now contains the volatilized contaminants and continues to be processed. Heavy particulate is removed from the airstream and reintroduced at the hot end of the rotary dryer, where it is recombined with the soil stream. The contaminant-laden gas stream is routed to the thermal oxidizer, where hydrocarbons are reduced to carbon dioxide and water. The system is capable of up to 99.99% destruction removal efficiency and meets the requirements for best available control technology. The thermal oxidizer consists of a refractory-lined combustion chamber utilizing a 42 million BTU direct-fired burner with a design operating temperature range of 1400 to 1800 degrees Fahrenheit and a 1 to 2 second retention time. The gases from the oxidizer must be cooled to a temperature for final particulate removal in the baghouse. This is accomplished in the vertical evaporative gas cooling chamber. The system operates by spraying atomized water into the process exhaust. The amount of atomized water is adjusted according to outlet gas temperature going into the baghouse. Ductwork leading to the cooling chamber and the cooling chamber entrance are refractory lined. Cooled gases enter the baghouse via an inlet air plenum that reduces velocity to promote initial particulate fallout while distributing the air over the cross-section of the baghouse. The gases then contact 1,216 bags that are divided into 19 modules. bags provide excellent removal efficiency and have continuous operating temperatures of 400 degrees Fahrenheit. The gases are pulled through the bags and into the clean air plenum of the baghouse. The clean gas is then directed to the ID fan and pushed to the exhaust stack. Particulate filtration is accomplished by the buildup of a particulate cake on the dirty side of the bags. A continuous pulse jet cleaning system sends compressed air down into the clean side of the bag to create a momentarily positive pressure inside the bag. This produces a shock wave that allows this material to fall into the hopper portion of the baghouse. The need for pulsing is completed automatically by the differential pressure sensor that indicates the pressure from across the bags. A system of screw augers collects this material and transports it to the soil discharge system, where it is recombined with the soil. The baghouse includes the induced draft fan that is mounted at the baghouse outlet. The ID fan is equipped with two 150 horsepower motors. The ID fan induces the process gases throughout the entire system while pushing these gases through the scrubbing system when used. The ID fan maintains a negative pressure throughout the system, which prevents any fugitive emissions. Testing is conducted to ensure compliance with air emission standards.